Hi, this is Thomas from Apex Game Tools. In this video we're going to look at the game world, which is a central object in Apex Path. If you saw the Getting Started guide, you probably noticed that we added the game world through adding navigational behavior to the unit. In this case we don't have any units, we just have an empty scene, so I'm going to add the game world directly to my scene by going to Game Object, Create Other, Apex, and Game World. And there we go, we have our game world. So we're going to go through each of these components, skipping a few of them, but starting with Game Services Initializer. This is a component that initializes some of the central game services to Apex Path. For instance, the messaging that goes on. It also makes these services available to you to use through scripting. Next up, we have the grid component. The grid is a very central part as well. It is what defines where you can go in the game world, basically, and it is what you can see the visualization of right now in the center of the scene. We're going to skip this because there is a dedicated tutorial about the grid. Next up is the grid visualizer, which is actually the one doing this visualization in the middle of the scene view. As you can see, turning that off will remove the visualization. Now we're going to skip this as well because it's tightly connected to the grid, and we're going to cover this in detail so we can cover all options when we cover the grid. Next up is the layer mapping component. Now this one we are going to go into detail with a little bit. So in order to do that, I am going to add some more components to my scene. I'm going to add some ground, I'm going to add some lighting, I'm going to add a unit, and I'm going to add a block, which is an obstacle. Now I'm also just going to use one of these settings on my visualizer so that it always draws the visualizations. I'm going to zoom in a little bit. There we go. So right now, as you can see, my grid visualization is all red. That means that the grid has not picked up on what part of my scene is walkable and which parts are not, and that's because it doesn't know about this level geometry. It can't decide if it's ground or if it's obstacles or if it's units. For that it needs some layer mappings, and for that purpose, as you probably saw in the Getting Started guide, if you saw that, we have this small component, rather simple, a mapping between a layer in Apex Path and a layer defined in the scene. Right now there are no mappings. Now I have already defined these layers in my scene. So the first thing I'm going to do is I'm just going to assign my level geometry to the correct layers. So I have this block, or wall, or whatever you want to call it. I'm going to put that in the blocks layer. I also have my ground. I'm going to put that into the terrain layer, and I think the unit is already where it should be, in the units layer. Yeah, so now my geometry is in the right layers. So now I just need to put in my mapping. I'm going to start with the middle one here. This is the required mapping. If you don't map this, then you will not be able to navigate at all. So I'm going to select and map terrain, and as you can see, it's no longer red. This means that it now knows that this terrain is actually, you can navigate this, all of it right now. Nothing is blocked. Now a quick note on this is that this is a mask, so that means that you can actually assign multiple layers. So if I were to assign the UI layer as well as the terrain layer, I can do that. Or I can just leave it at one layer. So normally you would probably just have one layer, but you could have multiple layers if you have your scene set up that way, that you have terrain in multiple layers or units in multiple layers and so forth. You can just do the entire mapping using this component. So as you can see now, we have a scene where everything is accessible. all the cells are now black, which means they're not red, which means they are accessible. But we have this big block in the middle here. And now the reason that is there and it's not blocking anything is that we haven't mapped this layer yet. So if you leave out mapping the static obstacle layer, which is optional, but if you leave it out, then you won't be able to have static obstacles defined in this particular way where you have a block layer. However, if I do map it, it will pick up on this being a block, and it will actually now, because it's in the center of everything, it will block 4 cells. And lastly, we have the unit layer. This is even more optional, if you can say that. This has to do with how you can select a unit. Right now this unit is nothing but a mesh, so I'm just going to add the ability to select my unit in the first place, like this. And when I start the scene, you can use normal selection by dragging a selection rectangle around it, and it will select the unit. However, I cannot click my unit directly and select it. Okay, I can only select it by dragging. If I want to be able to select my unit directly, I need to define a unit layer. So doing that, mapping there, will then allow me to select by clicking directly. So I mean, it's not a super important feature probably. So if you are struggling to get enough layers, then the order of importance is terrain, obstacle, and unit. Right, so moving on to the path service. Now this service is responsible for giving agents a path to follow. When an agent wants to go from A to B, it will request this service to give back a path. This service will then process the request, and if there is a path, it will give back a path, or it will give back an answer saying there is no path. So this is the pathfinding part of Apex Path. As you can see, it has a number of properties that you can set. The first one being the engine type. We have standard A-star, the normal pathfinding algorithm, and we have something called jump point search, which is an extended A-star algorithm, which is actually quite a bit more memory efficient, and also it's faster, basically, in most scenarios. Now, it's a little technical to go into when to use it and when not to use it. So the best way to find out is to, well, try it out, see if it works for your scene. It will most likely be faster if it works. If it doesn't work for your scene, it will show weird behavior for your units. Because the jump point search does have some requirements. So if you start using non-uniform grids where some fields cost more than others, now right now that is not the case, but that will be the case in later packages that we will be releasing. So select whatever you want. Both are valid options, and since these will not be impacting the frame rate, you can select whichever, basically. Now the next one is initial heap size. This is another optimization thing. Only worry about this if you get warnings in the console saying that you should increase this. If you get those messages, well, just increase it by an amount until you don't get them anymore, or you can also just ignore them. It is purely optimization, performance optimization. Next up, we have a cut corners setting. Now, cut corners means whether or not the unit will cut corners, or the path that will be given a unit will be cutting corners. By default, it's off, and I will show you the difference between cutting corners and not cutting corners. I'm just going to move my block so it is on a single cell, pretty much like that, so it only blocks this particular cell. Now if I move my unit from where it is and then I move it up here, you can see it moved in this manner here, in an angle there. However, if I enable cut corners, and start it again, and I move up there, you can see it actually tries to cut across right here. Cut the corner instead of going around here. And as you can see, it bumped into the obstacle. So this option is only viable if your level geometry is actually placed so that it would allow for the unit to get past the corner. So if I have it like this, for instance, the cell is still blocked, but it wouldn't be a problem cutting this corner because it can actually go across here. So now I can cut corners, no problem. But if my level geometry is aligned with the grid cells, then cutting corners is usually a bad idea because I will have my units impact the obstacles. Collide with the obstacles is the term. Alright, so I think that was it for cut corners. Next up, run async. This is on by default. Running async mode means that it will run the path service in another thread, which means it's much it doesn't impact frame rate in any way. It doesn't run in the main thread, and this is definitely recommended. Yeah, there's basically the only option, the only reason to turn this off is if whatever device you run your code on does not support multiple threads. Other than that, leave it on. Next, we have a thread pool option. Instead of using a dedicated thread, you can use a thread pool, but again, it is left off by default, and the reason it's left off is because usually dedicated threads are the best option. Now, lastly, we have a max milliseconds per frame. This option only makes sense if you do not run in async mode. Now, if you run in the main thread, you obviously don't want your Pathfinder to use up your entire frame. So this setting, you can set up how many milliseconds you will allow for the Pathfinder to use per frame. Only relevant if you run in synchronous mode like this. Alright, so next up we have the load balancer. Load balancers are the ones that ensure that we don't have big spikes on the main thread. Apex Path defines a few dynamic obstacles, scanners, and steering. And then we have some extras here because we have the examples scenes here in this project. So we have an extra load balancer and the default load balancer, which is always there. Now, load balancers, how to set them up, how to add your own, all that we will cover in another tutorial. Finally, we have an input receiver. Basic. This is what allows me to select my unit using my mouse. And there are a few other inputs that are supported, selecting groups and stuff using the keyboard. So this is a PC input receiver for using mouse and keyboard. And it's a basic one. And it is highly recommended that you replace this with your own, so that you can A, use the input manager, and B, put all your input receiver logic into one input receiver and integrate the Apex Path stuff in there. How to create your own input receiver will also be covered in a separate tutorial. So that was an overview of the game world. Hope it makes sense.